Hi everyone, I welcome you to the presentation of this lecture in analytical geometry. I'm presenting a topic on parabola. So by definition, a parabola is basically a set of all points in a plane equidistant from a fixed line D, which we are calling a directrix, and a fixed point F, which is the focus of the plane. So under parabola, we are going to look at four forms in which you can write the equation of a parabola. This one is a parabola centered at the origin, though it can be shifted from either left or right. But on this one, the focus is on the parabola centered at the origin. So you have this one, where you've got your x-axis and y-axis. You've got the parabola opening upwards like that. It will have a directrix given by y is equal to negative p, and the focus there given by f is equal to 0, p. So the directrix, the distance from the vertex there to the directrix is equal to the distance from the vertex to the focus. So if a parabola is in the y-axis and it's on the positive y like that, because from 0 going upwards here, this is the positive. So if the parabola is there, the equation of that parabola will be y is equal to 1 over 4px squared. So the reason we're saying it's y is equal to, it's because it's in the y-axis, and they always have this factor 1 over 4p. So 1 over 4p is positive because this parabola is in the positive y-axis, and whenever you have y as your subject, x will be squared this side. So this is the equation of a parabola like that. Then you have another scenario there where you've got your x and the y-axis. You've got the parabola in the y-axis, but this time around it's pointing down. So if it's pointing down, it will be almost the same like this. Of course, it's going to have the directrix. This time the directrix is y is equal to positive p, because the y that side is positive. But the focus there, because in the y-axis the value for x is 0, it's going to be 0, negative p, which is this one. The value for p here will be negative because it's in the negative y. And the equation of that parabola will be given by y is equal to negative 1 over 4p. Why negative? Because we are in the y-axis but on the negative side. That's why you are having that, which is equal to x squared. Then you have a parabola which is forming in the x-axis. Parabola forming in the x-axis could have one in the positive x-axis and the other one on the negative y-axis. So the one on the positive x-axis, it will be opening this side. Once you have that, it will have the directrix, which is x is equal to negative p. This time around it's x because this is the value for x, and the value for the focus there, it's going to be the value for x, which is p, 0. You have that. The equation of this one, since you are in the x-axis, it will be x is equal to 1 over 4p, as I said, will always be there. It depends when it's positive or negative. So since you're in the positive x-axis, then it's going to be positive 1 over 4p. And then if x was the subject, automatically the y will be y squared. And the last one, you have opening on the negative x. So from there, you know, directrix will be there, given by x is equal to p. And the focus given by negative p over 0. Then the equation of this one will be x is equal to, this time around it's negative because it's in the negative x-axis, which is that one. So these are the four equations of a parabola. You have that one, this one, that one, and the other one. Let's look at some examples. So find the focus and directrix for the parabola given there. And then the other one, find the focus and directrix for the parabola given like that. So for the first one, we are saying x squared is equal to negative 12y. So here, make y the subject. Make the one which doesn't have a square the subject. It's easier. So with the way it is here, you make y the subject. The equation becomes that. And then from this, we know the parabola which starts as y is equal to something. It's in two cases. It's in the y-axis. Either it's on top of the y-axis or below. It's on top if 1 over 4p is positive. It's down if 1 over 4p is negative. So as you can see here, will take the form of that one. It's in the y-axis, but it will point down. And once it points down, the directrix will be y is equal to p. The focus will be 0, negative p. So this is the equation. You just equate this coefficient to that. Once you equate those and you solve for p, you're going to find p is equal to 3. Once p is 3, it's very easy to find the directrix. So the directrix will be y is equal to 3, and the focus will be 0, -3. So those will be your values. That is your directrix, and that is your focus. Okay, for the second one, the equation has been given to be this. The one which doesn't have a square is x, so make x the subject. Once you make x the subject, we're having that. So this is a parabola which is in the x-axis. It's either pointing to the left or right. It will point to the right if 1/4p is positive, which is this one. It will point to the left if 1/4p is negative. But this one, since 1/4p is positive, it will point to the right. So you have a parabola which looks like that. So from here, you just need to find p, and it will be very easy to find the directrix as well as the focus. So you just equate 1/4p to this coefficient there. You're having that. Making p the subject of the formula, you're having p is equal to 2.5. And then from there, you can easily find the directrix. The directrix will be y is equal to 2.5, and the focus will be 2.5, 0. So this marks the end of the presentation on parabolas. Thanks for watching.